So here we are over in the singletons portion, the singletons package, and we'll see that there's an interface, which is the singleton interface. This defines a bunch of setter and getter methods for a singleton. I just have two, get field and set field. Obviously, if you had a singleton with more than a single field, you would have setters and getters for each field. So this is a generic interface parameterized by type T, and we can get the value of whatever is being stored, and we can also set that value, and it returns the old contents of the field before we set it. So let's go ahead and take a look at some different implementations of singletons. We'll start with one that is the one that I helped to popularize back in the day. This is 1997 or so. This is the Singleton V for the volatile singleton implementation. When I was a graduate student many years ago at the University of California, Irvine, I was reading the Gang of Four book. I was a reviewer of the Gang of Four book. I was also doing my PhD dissertation, which had to do with parallel processing of communication protocols. And I was trying to use the singleton pattern for some things, and I noticed it was failing catastrophically. And I was thinking, what is going on? And it became clear very quickly that there were race conditions that were occurring because the way that the Gang of Four implemented singleton, they didn't deal with locking. So there's a bunch of different ways to implement a thread-safe singleton. You'll see a couple here, but one of the problems with doing it the naive way, which is just to use some kind of a synchronized block over the whole instance method, is extreme in terms of locking when it's not necessary. So the way to get around this, one way to get around this is to apply something called the double-check locking pattern, or the double-check locking optimization pattern. If you take a look at this Wikipedia link, you'll read all about it. And it's a very interesting pattern. I won't go into the long history of it, but the key point here is that because this pattern was documented in pattern form, it made an influence. It influenced the way the Java virtual machine was updated with Java 5, which came out in 2004. And I think that's also described here at this link. And so what we're about to look at is the way you can use double-check locking with the enhancements that were made to Java and the volatile type qualifier. So let's take a look at how this works. So here's Singleton V, which is implementing the singleton interface. That's where we're going to get the field access, setter and getter methods, and so on. And then down here, we define ourselves a static volatile singleton V called S singleton. So this is volatile. Volatile, as you hopefully recall from watching the videos about volatile, it's basically a guarantee that reads and writes to an object of type volatile or qualified with the volatile type qualifier are guaranteed to be atomic. You either get them all in one, you read that variable in one fell swoop, or you don't. Very important. So this is a volatile variable. Notice that we have to make it a raw type because unfortunately we can't make statics be parameterized types in Java for a variety of reasons having to do with type inferencing and type erasure and so on. So just take it on faith that you can't make those things parameterized, but it's okay. We have ways of working around that. Here is a non-static field. You could have more than one field. This is the field that's going to be used by our setter and getter. Here's the singleton constructor. This is important to remember because when we run this program, you're going to see that this singleton's constructor only gets called once, no matter how many threads there are starting simultaneously to access it. So that's important, and that's what the volatile will be used for in a second. Here's the getter method. This returns the value of field. Here's the setter method, which stores the old value of M field, updates it, and then returns the old value. And then down here is the instance method that's implemented using the double-check locking pattern. And here's how it works. So we start out by making an assignment to a local variable of type singleton V, we call inst for instance, and that read of S singleton is an atomic read. So we atomically read the contents of that particular value into this local variable. We then check to see whether or not inst is null. If inst is not null, we've already been initialized, in which case we just go ahead and return that value. However, if inst is null, this is the first time in. Now, what makes this tricky is several threads could simultaneously be calling instance on the same singleton at the same time. So they might all find inst is null. And this is where the double checked part comes in. So if that's the case, if it is in fact the case that inst is null in one or more of these threads, then and only then do we synchronize on the class object for the singleton class. And that works perfectly fine. There's only one class object. You can synchronize on it. And therefore, one thread at a time will get through this critical section. And once it gets in there, we once again reassign inst from singleton. And that makes sure we've got the latest and greatest version. And then we perform the second check. This is the double check locking part. We check to see if inst is null. The first time that's the case, which is the first thread in, we go ahead and make a new singleton v, store it to inst, and also store it to s singleton. S singleton, of course, is the atomic access because it's volatile. So that will write through to that location in memory. At that point, the next thread that goes through this part of the synchronized block will discover that inst is no longer null, and it will skip calling the singleton v constructor. So that's essentially how this works. It's super cool, a little more ceremony than we might like, and we'll compare and contrast that with the alternative approaches. But it does, in fact, work. It implements the double check locking pattern, and Java's virtual machine semantics work properly for this use case with Java 5 and later.